C++ compilers read our code and translate it into a low-level intermediate representation, which a linker will combine into a final executable. Today I want to show you a few of the most relevant C++ compilers and how you can use them. A compiler doesn't usually come as a standalone program, but as an essential tool, part of a development environment, along with libraries, analyzers, optimizers, linkers, maybe a code editor, and other resources. Therefore, when we need a compiler, we usually install the entire development environment or toolchain it belongs to. But I would like to focus mostly on the compilers now, so I will try to only download the minimal setup to run a compiler in order to build an executable file. Probably the most popular, especially in the Windows world, is the Microsoft Visual C++ compiler, or shortly MSVC. It can compile both C and C++, and it comes with a Visual Studio development environment created by Microsoft. This integrated development environment, or IDE, is everything you need to begin creating Windows applications and so much more. The community version is free and is packed with many workloads and components to choose from, depending on what you want to build. For C++ projects, you must pick the desktop development with C++ workload and install it. If you want to run a compiler and the basic tools from a command line, without an IDE, you can just install the build tools. The Windows Software Development Kit is also required if you want to build Windows applications, so we have to download and install it as well. To be able to run the compiler from the command line without errors, you'll have to set some environment variables containing essential headers and libraries that are installed with MSVC and a Windows SDK for a minimal working environment. You can do this by executing a batch file that does it for you automatically and has been provided with the build tools. You can specify what platform you want to build for and what SDK version to use, which you can look up in your SDK folder. You can also just start a developer command prompt from the launcher or the shortcuts created in the start menu and have all the environment variables set for you. Either way, once the paths are set, you can compile a code file with a simple command like this one. The option after the file name specifies the exception handling model support generated by the compiler, that is, how exceptions are going to be handled. There are many other options and you can see a full list of them and what they mean at the link I will append in the description. Another well-known compiler that you can use on Windows is GCC, the GNU compiler collection. Though it can't beat MSVC in some aspects, therefore it's more recommended for Unix or cross-platform software than Windows applications. For Windows, there have been two main ways of installing GCC, Cygwin and MinGW. Cygwin emulates an Unix environment, providing some Linux functionalities on a Windows system, and is a recommended choice if you're trying to port Linux apps to Windows. As you can see, there is an immense list of Linux tools and libraries that you can install on a Windows, including the GCC compiler. Of course, you will have to add the bin folder to the path environment variable so you can call GCC globally. MinGW, on the other hand, is just a port of the GCC toolset for Windows. MinGW is faster and better suited for building Windows apps. There are several pre-built packages and you can even install it through Ciguin. I'd pick the standalone version for Windows, for example. Just unzip it somewhere and add the bin folder to the path variable like before. By the way, make sure the Ciguin folder is no longer in the path variable, or is placed below the MinGW folder, so that the right compiler will be called. If you have Windows 10 or 11, you can also run GCC from WSL, the Windows subsystem for Linux. This will give you the possibility to run a Linux terminal from Windows and install GCC in the same way you would do on a Linux. Installing the WSL is a topic in itself, so I won't show it in this video, but it's good to know that you have that option too. Now on Linux, installing GCC is child's play. Just open a terminal, do the regular update and install the Build Essential package. And now you can just call the compiler like this, regardless of the platform. Many other options for GCC are listed in the page that I will append in the description. If you run a Mac and you have the Xcode IDE version 4.2 and above, you will find that the default compiler for C++ is Clang. This is a relatively new compiler, part of the LLVM project, and you can also obtain it by downloading the command line tools package, which contains only the basic tools to compile code, including Clang. Just like with the previous compilers, Clang can compile your code with a simple command like this. Notice how I specified the C++ standard to use, C++11, and the output file. A reference page of all the options that you can use with this compiler can also be found in the description. GCC is also installed with the command line tools package, but Clang has more advantages when it comes to performance, especially for big projects. Of course, Clang can also be run on Windows, either through the Visual Studio IDE installer, Ciguin, or by installing the entire LLVM toolchain, which will give you the latest version released. Don't forget to add the bin folder to the path variable if you want global access. On Linux, it's as easy as always. Install and start compiling. Other compilers worth mentioning are the Intel C++ compiler, with support for Intel processors and Windows, for which you also need Visual Studio installed, Linux and Mac systems. And the Oracle C++ compiler, part of the Oracle Developer Studio IDE and targeting Solaris operating systems. If you're just starting with C++ and want to give some code snippets a try, see what they do, test some algorithms, or just learning the ropes, you may as well just use an online compiler. This way you don't have to install or set up anything. Some of the online compilers that you could test your code on are Compiler Explorer at godbolt.org. It supports many languages and compilers and offers some interesting tools. Online GDB, also with many languages and the possibility to specify command line options. And online CPP with a clean interface, dark mode, and a button to download your code as a file, among other features. All the links are in the description. So I hope now it's easier for you to decide which one to use and how to get started. Running a compiler from a command line is recommended if you are learning C++ and want to know more of the processes that take place under the hood and the specific of each implementation. For productivity and speed, it's always better to use an IDE that will take care of all the tedious parts of the workflow and let you focus only on the coding and designing of your apps. If you know about other compilers, please share it in the comments. At some point I want to have a deeper look at each compiler in my list, but for now, thanks, give it a like and subscribe.